Okay, as we move to the end of Module 1, we get into the section that maybe students don't appreciate quite as much because many kind of hear the term math or many measurements and terms such as that, and they automatically kind of shut down a little bit. And so students kind of get a little anxious when it comes to some of the things we're going to talk about in the next section related to measurement systems and some simple math calculations that you're going to have to do. So what we want to be able to do, and the reason we make this part of this class, is when you look at measurement systems and calculations used in the human body, we're going to talk about the English system, which we commonly use day to day as we talk about pints and quarts and ounces and miles and some of those things, versus what do we actually use in the medical field and what do we actually use in the scientific field, when it's totally different, because now we're using the metric system or the international system of measures, and I'm going to talk about the differences between those related such that we're going to use grams and liters and milliliters and microliters and micrograms and picograms and nanograms and some of those crazy things which make it sound hard, but you're going to see here in a minute that it's far more simplistic than sometimes we think that it is. And obviously worldwide we are a minority from the standpoint of not using the metric system and those types of measurement systems. So the reason it becomes important to us as healthcare providers is that we have the opportunity to use the metric system to a great degree. That, for example, let's say for a pediatric patient, you're going to be giving that patient medications in dosages such as milligrams per kilogram of body weight. So we're giving them a certain number of milligrams based on their body weight in a certain number of kilograms. Well, most of our scales aren't measuring kilograms, or we don't have them measure kilograms, they measure pounds. So we've got to do that conversion from pounds to kilograms and then know, okay, I've got a certain concentration of this liquid medication, that it's got this many milligrams of drug in this many milliliters, and to be able to give that dosage correctly. And I could be speaking a little bit in error, but I don't think I am. All of the programs within the College of Health Professions, at the beginning of each of those programs, goes through and gives the students the opportunity, requirement, that they complete a math section. One of the first things you do in the nursing program is do a big medical dosage IV calculation math unit that a certain minimum standard has to be passed. The medical laboratory science program in their clinical chemistry courses has a specific math section that they cover these types of calculations. So it's a big part. Respiratory therapy does the same thing. So it's a big part of what we do as healthcare providers. So we're going to cover that a little bit. Now, if you kind of look at the English system, so the next two slides are going to kind of demonstrate the relationship of how complex one is versus another. If you go back in history and look at measurement systems, as we talk about bushels and pecks and hectares and all of those different types of measurement systems that have evolved with time, because they've been kind of pieced together, there was no standardization to that. So if you look at the English system and its relationship of, all right, if we're looking at as length as our parameter, we have the foot and the yard and the mile. Now, notice I've made a correction here to the table. Make sure you make that correction in your book. It was caught, of course, after everything was set off to print. And so instead of 1 yard being 9.144 meters now, it's moved the decimal one. It's 0.914 meters. So do make that correction in your book. But notice how complex this becomes when we look at the English system and we're looking at measuring length. We've got to know foot and yard and mile and the conversion between those. That a foot is 12 inches, and then a yard is 36 inches, and then a mile is 5,280 feet. I mean, those are just numbers that just aren't as intuitive. Now, we use them frequently enough that we pretty much know them, but there's just not kind of a general rule to those. As we look at measuring mass, and we look at grams and ounces and pounds and tons, the same thing is true, that we look at, 16 ounces is a pound and 2,000 pounds is a ton. And as we measure volume and as we measure both liquid volume and dry volume, just these numbers get quite cumbersome. But if we compare that to what we know as the metric system, we'll notice how small this table becomes. And there's an advantage to this from the standpoint of that the metric system is based on the power of 10. So each time we move from one unit of measure in the metric system, we're moving a given power of 10. So as we go from centimeter to millimeter to micrometer to, we're moving a given number, but each time we move, it's a power of 10. Now we may be moving. Okay, now maybe another way to think about it is if you think, let me draw this, if we take this number, 1, 2, 3.4, 5, 6, 7, okay, if we take that number and understand, well, remember in probably elementary school, when your instructor made you, your teacher made you identify what was the value of a given number within a number, okay? And what I mean by that is, well, what's the value of this 1? Well, the value of this 1 is 100. Well, what's the value of this 2? Well, because it's my tens digit, okay, well, the value of that is 20. Well, what's the value of this one? Well, that's my ones digit, so the value of that is 3. As I get down here into the decimals, well, this is tenths, and this is hundredths, and this is thousands. So notice, as we move from hundredths to tenths, well, how much of a move is that? Well, it's 10 times. So as I move from tenths to ones, well, there's another 10. As I move from ones to tens and tens to hundreds and so on and so on. So each time I take this decimal and move it one way or the other, and I don't care which way I move it, it's the value of 10. So the advantage of the metric system is the fact that we have a base unit of measure. And those base unit of measures being, when I'm measuring length, I'm measuring meters. When I'm measuring mass, I'm measuring kilograms. Now initially it was grams, but they're just too small and we got these great big numbers. And so we use kilogram as the base unit of measure. When we use time, we use seconds. In volume, we use liters. In amount of stuff, okay, we use moles. And so these are the base units of measures, and then we just modify those base units with prefixes, kilo being one of those prefixes. And each of those prefixes means something. We're going to get into those a little bit. So as we want to change what we're representing by a given length, because I can say, all right, if I'm driving to Vegas, I can give you that number in meters. That's a horrible number, but I can give it to you. But it's better that I'm giving it in kilometers. And so I'm saying, all right, my base unit of measure is meters, but I'm saying that what I'm giving you, that kilo means 1,000. So each, for whatever number I'm giving you, okay, 623, whatever it is, that means 623 kilometers, but each one of those kilometers is 1,000 meters. Well, I don't want to give you 623,000 meters to Las Vegas from a given point. Now, I just want to say 623. So it allows us to change the number we give by just changing that prefix. So we don't have to deal with these great big numbers or really, really small numbers. We can represent them in a different way. So that's what gives the advantage of using this system of measures. Now, to kind of compare, well, what's meant by this metric system versus the international system of measures? The difference is the metric system was created in France in the very late 1700s, like 1799. And then it has undergone a number of changes. Well, the goal was to get a standardization. So the metric system was kind of the original system, and the international system of measures was what the international community tries to adopt as a standard. And there are additions to the original metric system and changes from the original metric system, but we commonly use them synonymously. Okay, we're using the metric system, but understanding that it's been standardized, and so it's also the SI system, or the International System of Measures, the original French term, and that's where the term SI system comes from. And no, I don't even stand a chance of reading it. So, so you can basically treat as synonyms the SI system and the metric system, just understanding that the original was the metric system, and we are then using it to make a more simplistic way to measure things and create things, and okay, with the rest of the world, because essentially, okay, the United States uses the English system. England uses kind of a modification of that, kind of the imperial system of measures, which is kind of a mismatch of English system and other measures. There are a few countries that are said to still use the English system, but by and large the world. Now, the United States was actually in the 1800s, I think it was around 1860, 1870, was one of the first to adopt the metric system as a standardized system, but just not implement it. Okay? And we've become, quite used to our pints and quarts and ounces and gallons and things of that nature. So we've kept that. Obviously not in the scientific community, okay, and also not in the medical community.